Hi guys, today we'll be talking about twilight, and there are three areas that we'll be focusing on. So firstly we'll be talking about what is twilight, that is A, and then we'll talk about the different types of twilight, right? And the third thing we'll be doing is we'll be calculating the time of twilight from the Nautical Almanac, and this is done to get the right time for which we can obtain the star size using the sextant on the ship. Alright, so let's get to it. I want to keep this video short. So the first one is what is twilight. So let me read out what I've written here. Twilight is, in order to observe the altitude of a star, you need to be able to see both the star and the horizon at the same time. Alright, so theoretically sunrise and sunset are deemed to occur when the sun crosses the celestial horizon, right? However, even when the sun is below the horizon, some light is still visible for a while, and I'm sure you have observed this on the ship or generally. This period is called twilight, is arbitrarily considered to end when the center of the sun sinks 18 degrees below the celestial horizon and begins when the sun rises to within 18 degrees of the horizon in the east. Alright, so this is celestial. So when the sun goes down below the celestial horizon, you can still see some kind of illumination, some kind of light which emits from the sun, which still keeps the horizon visible, and that is called twilight. The twilight starts to occur right when the sun has dipped below the horizon, that is 0 degrees, all the way to 18 degrees below the celestial horizon. Alright, so there are three types of twilights, and this brings us to the second point of focus here. So the first type of twilight is your civil twilight. Now civil twilight starts to occur when the sun's center is between 0 degrees when it has just dipped below the celestial horizon up to 6 degrees below the celestial horizon. That is civil twilight. All right, at this point of time the horizon is bright, you can see the horizon, but the sky is too bright for you to be able to see a star most of the times. Sometimes at just towards the beginning or the end of the civil twilight, you can sometimes see both the star and the horizon, but most of the times the horizon is bright enough, but the sky is too bright for you to be able to observe all the stars. Then the second type of twilight is your nautical twilight, which is the period of time when the sun's center is between 6 degrees below the horizon and 12 degrees below the celestial horizon. So this is after the civil twilight when the sun is setting, and this during this time it's perfect for star sights because the sun has dipped between 6 and 12 degrees, so your horizon is bright enough, but also your sky is dark enough for you to see the stars, so you can see both the stars and the horizon for the star sight. So this is the ideal time for you to take a star sight. And the third one is the astronomical twilight, when the sun's center is between 12 degrees and 18 degrees below the celestial horizon. And during this time, the horizon is too dark, you can't see the horizon, and the sky is dark enough for you to see all the stars. So even though you can see all the stars, you can't see the horizon for a star sight. So the ideal time is normally the nautical twilight, or the end of the civil twilight and beginning of nautical twilight is the ideal time for taking star sights. All right, so in the third topic for today, we'll be learning how to find out the zone time or the ship's time for calculating civil or nautical twilight. It's the same one. So in the almanac, the times given to you are for the civil and nautical twilight, because sometimes in the middle of the civil and towards the beginning of the nautical, you can start to see both the stars and the horizon. It's a good time for you to get your sextant ready, go and stand on the bridge wing and start observing the stars and get the star sight for position calculation. Alright, so somewhere between civil and nautical is the perfect time for you. So let me take an example for a question where you have to find the ship's time, the zone time of morning civil twilight on 15th of September 2004 in a position 33 degrees south and 112 degrees east. Alright, so to do so, first thing we have to do is we have to go into the Nautical Almanac, and when we go into the Nautical Almanac, 15th, 16th and 17th September, for the same 3 dates, you have the times given to you. I'll show it to you very quickly. So, but the time that you obtain from the Nautical Almanac is your LMT time, which stands for your local mean time. Alright, so let's go into the Nautical Almanac. So if you go into the Nautical Almanac here, you can see that the times for the date of 15th, 16th and 17th September, you have the same times of civil and nautical twilight. It's given here with this column, you see. So I will zoom in very quickly. When you zoom in, you can see that the time is given here. right? And these times are all your local mean times or LMT times. Although when you know, if I zoom out, you can see that the time on this side is GMT. On your left side of the page is all, this is all GMT, but on the right side of the page, when you zoom in, all these times are given to you in LMT or local mean time, right? So here, of course, the date is 15th of September. The latitude is 33 degrees south, remember. So from here you can see that this is 0 degrees, and upwards from 0 degrees is all your northern hemisphere, and downwards is southern hemisphere. So you can see the times given to you are for civil and nautical twilight and sunrise times. These are the three. And then at the bottom, of course, over here is your sunset time and your civil and nautical twilight during the sunset. Alright, so getting an idea of these times helps you to get your sextant ready, go and stand on the bridge wing and find out what is the time that you can get the star sight, when you can see both the star and the horizon. Alright, so for 33 degrees south, if I need the civil twilight for morning sights, you can see that this is 30 and this is 35. The times are the same, it's 5:33 and 5:33 for 30 and 35 degrees, right? So if it was different, we would have to apply a correction, but normally the times are not so different. So here, of course, for 30 and 35, both its time is 5:33, so that's the time we'll take for 33 degrees south as well, right? So for 33 degrees south, we have the LMT time for 15th of September, it's 5:33. The next thing I do is apply my LIT to obtain my GMT. Now what is LIT? LIT is nothing but longitude in time. Alright, longitude in time, and you get that by dividing longitude by 15. The answer that you get is your in hours and minutes. So I divided 112 degrees by 15, and you get is 7 hours and 28 minutes, right? And you subtract it because you are in the east longitude. Now how it normally works is, of course, your 000 degrees longitude is your GMT time. It observes your GMT time. Then of course on either side till 7.5 degrees on either side, east and west, this is east, and 7.5 degrees west, they are keeping GMT time as well. This area is keeping GMT time as well. But then as you go further east, every 15 degrees, for example 22.5 degrees or 37.5 degrees, every 15 degrees of longitude, you will add an hour, you add hours to it, right? So if your ship is on the east side, you are ahead of GMT, and that's why I am subtracting the LIT or longitude in time to obtain my GMT. So because my time on the ship is ahead of GMT, GMT is behind me. But when I subtract 7 hours 28 minutes from 5:33, I go back into the previous night, 14th of September. This becomes 14th, and the time becomes 22:05. But to obtain my ship's time or my zone time, I have to apply the zone. Now how do I get my zone? My zone is of course depending on the longitude in time. Depends on the longitude in time. I should not write equal to, depends on longitude in time. So how it works is, you take your longitude in time, which in this case was 7 hours and 28 minutes. Alright, now in this case it gives you the zone. So because it's less than 30 minutes, my zone is +7 because it's in the east longitude. So what this tells me is basically every 15 degrees that I go from 7.5 degrees east, I'll add hours to it. My ship is 112 degrees east longitude, so I have to take a round figure because most of the countries, they have a round number as their time difference from the GMT. Now there are of course some countries like India which has a time of 5 hours and 30 minutes, but most of the countries, they keep a round number, alright, because it makes calculations easier. You can't keep a time based exactly on your longitude, it will make business very difficult. So because we are on the east side, our zone is depending on our longitude in time. Because it's 7 hours and 28 minutes, our zone is +7 east. +7 means we are 7 hours ahead of GMT. If it was 7 hours and 35 minutes or something like that, my zone would be +8 hours east, because then I would be 8 hours ahead of GMT. Similarly, if it was west longitude, my time would be -7 and -8. So because I'll be behind GMT, GMT would be ahead of me, right? But in east longitude, I am ahead of GMT. So my ship's time, ship's mean time or SMT or zone time, I will add back the 7 hours, and then I come back onto the 15th of September, and my times become 0508. That is the time of my civil twilight in the morning. You do a similar thing if you have to calculate for nautical twilight. You apply the same corrections. Alright, so it's pretty simple, pretty straightforward. So in this video we discussed what is twilight, what are the different types of twilight, which is twilight is the best for taking sextant sights, and how do you calculate the twilight time from the Nautical Almanac. Alright, thanks guys, we'll see you.